So today we're going to talk about the spring equation. Most people think of F equals kx, but that's a simplified equation. It says that the force is proportional to the displacement x. To displacement x. But the problem is it assumes two things. It assumes the home position is 0 and there is no offset. These assumptions do not hold for the camera project. A better equation is F equals K delta x plus B. This says that the force is proportional to the deflection delta x, and there is an offset given by B. This is a linear equation. It looks like y equals mx plus b, where you can think of F K delta x plus b. Delta x is a deflection given by delta x is given by the position x minus a home position x naught. So x naught is an initial length of the spring. It's the initial length of the spring when there is zero force. X equals the length of the spring at a particular force. Excuse me. So let's do an example. We do an example. Let's say F, the force, equals 0 pounds when x naught is 2 inches. So you measure the spring on the table and it's 2 inches. Let's say F equals 4 pounds when you measure the spring when you put 4 pounds on the spring and you measure 3 inches. And F equals 6 pounds when x equals 4 inches. So in this example, delta x is 3 minus 2, which is 1 inch. And here delta x is 4 minus 2, which is 2 inches. So now we have the equation F equals K delta x plus B, an offset. Many people want to say that the stiffness K is F divided by delta x. This does not work. You'd have to, with this equation, you'd have to say F minus the offset equals K delta x, or K equals F minus B divided by delta x. So let's do a little algebra here. If we do some algebra, the force was 4 pounds My K I don't know yet, and my delta X was 1 inch, and I have an offset B. And then my force was 6 pounds, and I don't know what K is yet. And then my delta X is 2 inches, and I have an offset of B. You would want more points for Excel and for homework, but I'm just going to do 2 points here. So for this example, then you'd have 6 equals 2K plus B. You'd have 4 equals 1K plus B. If I subtract the two equations, I get 2 equals K plus 0. So K equals 2 pounds per inch. K equals 2 pounds per inch. Look here, if I had done K equals F divided by delta X, which is not right, you would have said F was 6, my delta X was 2. You would have gotten 3 pounds per inch in one case, and you would have said K equals F divided by delta X. You would have said in the other case, you would have had 4 pounds divided by 1 inch. You would have had 4 pounds per inch. And both of these are wrong. Okay, so we're finishing up the spring equation, and we said that F equals K delta X plus B, but we found from doing some algebra that the force equals 2 times delta X plus B, where K was 2 pounds per inch in this case. So we'll plug in 1 point, which was F equaled 4 pounds when delta X equaled 1 inch. So now we have 4 equals 2 times a 1 plus a B. We have that B equals 2 pounds. So now our equation is F equals 2 delta X plus 2. For check, we can check the other data point to see if it was right. We had F equals 6 pounds and delta X equals 2 inches. So we have 6 equals 2 times 2 plus 2, which is 4 plus 2, which works. What does this tell us? This tells us that the spring constant K is 2 pounds per inch, and it tells us that there was an offset of 2 pounds. The offset tells us that it takes a little bit of force to actually pull on the spring. So if I was to take the spring and put it on the table, it actually takes an initial value of 2 pounds just to get the spring started. And in an extension spring, they typically have a certain amount of force just to get the spring started. So if we just to do a simple plot, our plot is going to look something like this, where if this is force and this is delta X, you're going to have an upward slope. The slope is given by 2 units by 1, and this offset is given by